All right, my lovely sixth graders, we're going to do part two, take two basically, of these notes because in the middle of the first one, wouldn't you know there was a student out there shooting a TikTok video? I know. All right, well, to what we need to do today, which is to learn how to solve and write. We're going to learn how to solve and write equations that have addition or subtraction with them. All right. Our essential question is going to be, how do I solve an algebraic equation with addition or subtraction? So that is our essential question. That's what we're going to learn how to do today. Now, before we do that, as you can see, I have this picture of this howling wolf right here. Yes, I have this picture of the howling wolf because our goal is going to be to isolate the variable. And when we do that, we're going to howl because we've accomplished our goal. We're going to be excited with I'm looking for the word, with great jubilation, because we will have accomplished our goal. So without further ado, let's define what an equation is, because we already know what an expression is. Now let's look at what an equation is. An equation is a mathematical sentence showing two expressions are equal. So for example, when you see something like x plus 9 equals 15, that's an equation. We have this expression over here made up of our variable, our operator, and then our constant. And on the other side, that's why we have this equal sign here. On the other side, we have 15. So we're saying some number plus 9 is going to be or have the exact same value as 15. All right, that's an equation. Well, your standard this year is to learn how to, from word form, write an equation, as well as how to solve the equation that you wrote. So we're going to start with the write part. Just like when we were writing expressions, the first thing we need to do is define the variable. There we go. We're going to define the variable. Now, if there is no point, if it doesn't require us to define the variable, so if it says something like the number, this number, or like in the first one, the sum of m and 17 equals 25. Well, when we have that, then we don't need to define it. But in most cases, in our basic word problems, we are going to want to define the variable. And I'm going to rewrite that because it's all messy now. And because I have whiteout tape. There we go. We're going to define the variable. The second step, which is the super important part, is to find or look for the keywords. These keywords are going to tell us what to do with our equation, like what operation to perform and where the numbers or the letters need to be. So it's really important that we find our keywords. All right, we're going to go over here to the left-hand side, and I'm going to finish this out because it got cut off. So ultimately, right now, we're going to work on the right part of the write and solve an equation for each example. So for example A, we have the sum of m and 17 equals 25. All right, to start, we know sum means we are finding the answer to an addition problem. So at some point, we're going to be adding. And is a connecting word. So we're going to see that it connects something. In this case, it's going to connect m and 17. And then we know it's going to equal 25. So we would start with the sum of, so we know that that means we're adding, so it's the answer to an addition problem, m and 17. So 17 and m are connected, and we know it's an addition problem, so we can put addition between the two. They're connected through addition, equals 25. We have our first one written. Let's go to example B. The difference between x and 9 is 15. So as we look at this, we can see we have the connecting word and, so we know that's going to connect x, and we can see right here 9. Those are going to be connected. And then we have difference. Now, as you know, difference means it's the answer to a subtraction problem. So we will be subtracting in here. And then we also have is, which we learned from when we were working with percents. Is means that's where you're going to put your equal sign. So we have all the parts we need to write this equation. So we have x and 9 being connected. So x and 9. And we know they're connected through subtraction because we're finding their difference. So the difference between x, this number we don't know, and 9, we're saying it's going to equal 15. All right, from here, that is how we write an equation based on keywords. So that's an example. Now the second part, so back up here to the notes, going to zoom in a little bit. Let's see if I get that right. Whoop, looks good. All right, the next part is learning how to solve an equation. All right, to do this, it's very important that the first thing we do is we want to figure out what's happening to the variable. So we're going to identify the operation in the problem. So for example, the example we had before, we can see the operation here is addition, because that's what's happening to the x. We are adding 9. Okay, next, then we're going to use what's called the inverse operation, which inverse, you know, is just a fancy word for, oh, I dropped my pen. Inverse is just a fancy word for opposite. So basically, we're looking for the opposite operation. We like to call it's the operation that would undo addition. So to undo addition, we would have subtraction. For our example, so back to our example, if we were to undo addition, we would have subtraction. So first we find what is happening to the variable, our operation, and then we're going to use inverse operation, so it's opposite, to do what our goal is, which is to isolate the variable and solve for its value. That is what must happen. So that's our whole goal. When we are looking at an equation, we're always looking to figure out what is that number that is represented by x. Okay, now when we're doing this, there are a few things that we must do all the time. So I'm going to highlight it because it's that important. It's one of those things that if you don't get this down this year, then it's when you get to 7th grade, 8th grade, and beyond, if you can't do this skill, then you're not going to be able to solve the equations. It's that simple. I mean, it's easy now, but we're working towards the future. So we have to keep that in mind. All right, as mathematicians, when we are solving an equation, the thing you must keep in mind is that you have one side of the equation compared to another side of the equation. We need to keep both sides always equal to each other. We call it keeping them balanced. So with that, you're going to keep the equation balanced, which simply means whatever you do to one side of the equation, you must automatically do to the other side as well. It's kind of like when your parents are handing out cookies. If they give you a cookie, but they don't give your little brother or sister a cookie, then what do we hear? A bunch of whining and complaining, I didn't get a cookie, and nobody wants to hear that. So instead, your parents are making it fair. They're going to keep everything the same, consistent, and give you each a cookie. So that's what it is. Whenever we are working with an equation, we want to keep it balanced and fair. Now, to help me remember where one side is versus the other, that's why we have our equal sign. For now, I'm going to put in my Great Wall of China, just like a divider, so I know here's one side of the equation that's equal to the other side of the equation. Okay, from here. Now, it's always important that you show how you're isolating the variable. And we're going to do that through what is called our properties of equality. That's really what it is. You're using your properties of equality. And you're like, what? Another property? You're right, there is. They're just rules. They help us to, live up to our standards. They empower us. So, properties of equality, we're going to show that. And then finally, you will know when you are done, when you get x, or the variable, all by itself, when it looks like this, it's isolated. You have x is equal to some number. Once you do that, then you can basically howl, oh, because you will have done a great job and you would have gotten the answer correct. All right, from here, let's go back to example A. We have m plus 17 equals 25. We wrote the equation. We're identifying what operation do we have here? We have addition, which means to undo it, the inverse operation would be to subtract. Now, if you have a colored pencil, this would be a perfect time to use it because we want to identify what's happening. So I'm going to subtract. But first, let me put in my Great Wall of China so we can see here's one side, here's the other. So I make sure that if I take 17 away from this side, I also go over to the other side and take 17 away. Now I know we're going to keep it clean. So these essentially cancel out. You're like, oh, those are gone. And you end up with m plus 0. But because of our identity property, we know m plus 0 is just m. So that's our variable by itself. Hip, hip, hooray. And then all we do is this little problem here. 25 minus 17, we get 8. So the solution, the only number that would make this a true statement where some number plus 17 equals 25, the only one that would be true for that would be the number 8. We've solved it. We found our solution. Now we can howl. Oh! Try it. I know you'll like it. It's fun. It's very releasing because you've just completed a task. All right, next to our next one. We have the difference between x and 9 is 15. All right, as we can see here, what's happening to x is we're subtracting 9, which means to solve for x, we have to use the inverse operation, which would be addition. So I'm going to put in the Great Wall of China so I can see this is one side, that's the other side. What do I need to do here? I need to add 9. I'm going to do the opposite. And whatever I do to one side, I make sure I do on the other side so it stays fair and balanced. These cancel each other out. So we end up with just x, our lone wolf, exactly what we want. And that's going to equal 24. Oh, such a great job. All right, from here, when we are solving equations are one of those things where you don't have to leave a test. You don't even have to leave your homework out and know that it's not done correctly because we have this little check step. So I'm going to put that in. We have a check step, meaning when you take the value that you got, the solution 8, and you place it in the problem instead of the variable. So instead of putting m plus 17, I'm going to put 8 plus 17. When I solve that, it should give me the 25 if I did it correctly. Now 8 plus 17 is in fact 25, and my original problem said it would equal 25, which means check, I got it right. That means I can leave with confidence knowing that my value for m is correct. So my solution for m is correct. Same thing with the next one. I can do my check step. So if I take out x, so we had x minus 9 equals 15. If I take out x and put my solution in, 24, take away 9, is that going to get me back to what I wanted? Well, 24 minus 9, indeed you borrow 15. And you'd do the work, you'd actually do the work, and you'd be like, okay, it does check out. These numbers match, which confirms that my original solution is correct. So I know it seems like extra work to go do the check step, but if you do it, then you will know without a shadow of a doubt that you got that solution, that problem correct. All right, to the next ones. Here's a test-like type question, one that we might see at the end of the year. Write the value for p that makes the given equation true. So we know if it's going to be true, then these values, this 2n 2/3 plus p, has to equal 5.5. So I'm going to put this over here in example C. So I have 2 and 2/3. I'm adding to that an unknown value, p, and I'm saying it's going to equal 5.5 when I put them together. All right, just like before, no different. Just like before, we're going to put in our Great Wall of China so we can identify one side versus the other side. And here it says that 2 and 2/3 is being added to P. So to undo that, we would need to subtract. So again, you're just going to do its opposite. So I'm going to take 2 2/3 from this side, which means whatever I did to this side, I also have to do to this side, 2 2/3. Bringing me to P is equal to, and now we have to solve it. Now we want to keep this space clean and neat because we want the answer to fit nicely there. We don't want any unnecessary mess. So I'm going to go down here and do my sidekick side work because you know we're all superheroes. But superheroes sometimes need a sidekick. So bring out your side work. So I'm looking at 5 1/2 minus 2 2/3. Now as I look at this, I'm like, hey, let me change them into improper fractions. That way I don't have to regroup and work with that mess. So 2 steps, multiply, add, multiply, add. So 5 times 2 is 10 plus 1 is 11 halves. Minus 2 times 3 is 6 plus 2, 8/3. Perfect, perfect. Next step would be to make them the same denominator. So right now they're not. So this is where you find your least common multiple. So coming back in this case, 6. So then you're going to ask yourself, 3 times 2 gives me 6. So I'm going to multiply 8 by 6 and I get 8 by 2. Oops, my bad. And I get 16. And then 2 times 3 gives me 6. So I'm going to do the top by 3 for 33/16. So now I'm running out of space. And this is one of my favorite parts when we're doing fractions that have the same denominator. I smile. You should smile too because they're super easy when they have the same denominator. All you have to do is keep the denominator 6, do the math on the top. If you need to go off to the side and do it, even better. 33, oops, look. Hot mess. 33 minus 16, so I'm going to regroup. That's a 2, that's a 13. 13 minus 6 is 7. 2 minus 1 is 1, and we get 17/6. And you're like, woo, that's my answer. Sweet. Oh, man, I did all that work and you couldn't even see it. Oh, let me go back. Well, I subtracted. We get 17/6. From here, we're going to state, let's just change it back into an improper it's in an improper fraction. Let's change it to a mixed number. Simple, simple. You see this fraction bar, it simply means you're dividing. It's the bottom number, 6, into the top number, 17. How many times does it go into 17? You're like 6 times, let me guess, 2 for 12. With how many pieces left over? 5. So there you go. You have 2 and 5, 6. That's how you make it. So answer would be 2 and 5, 6. That's the only value that would make the above statement for P true. All right, and finally, we can't leave out decimals. No, no, no. We like them, we want them. We like them, we love them. We're getting a whole lot more of them. So let's see. Another test type question. Write the value for S that makes the given equation true. So again, we're looking for what does S need to be so that both sides are actually equal to each other. So I'm going to copy that down. I have S minus 13 and 56/100 is going to equal, and I'm running out of space over here, so I'm going to write this here, 12 and 32/100. All right. Now, again, we're going to ask ourselves, what is happening to my variable? What do I see happening to the variable? We are subtracting from it, which means to undo it. To do its opposite, we are going to add. So we need addition. All right, from here, again, Great Wall of China. Whatever I do to one side, I want to make sure I do to the other. So I'm going to add 13 and 56/100 to this side, which means the other side gets to have 13 and 56/100 together. And hopefully you remember to line up them decimals. All right, so we get S all by itself. It's its own lone wolf. Yes, one more time. Let's howl. Ow! And then all we have to do is add. 2 plus 6 is 8. 3 plus 5 is 8 as well. Drop that decimal down like a tot. And then we have 2 plus 3 is 5. 1 plus 1 is 2. And we get our value for S. So the solution for S that would make this a true statement would be 25 and 88/100. Whew, that was fun. Can't wait to see you in class for more practice.